Okay, so today we're going to do what is called scientific notation. And this is actually pretty important, and it's easy because you are going to use this in your chemistry, you're going to use this in biology, all your science classes, you're going to use scientific notation. If you have any inkling of wanting to become an engineer and you're going to take my engineering class later on, we will do scientific notation quite extensively. Okay, all right. All right, 4.7, page 206. We're going to talk about scientific notation. In the middle, there is a beige box there. Using scientific notation. A number is written in scientific notation if it has the form of c times 10 to the nth. If it has the form of c times 10 to the nth, where c is between 1 and 10. C can be equal to 1, but has to be less than 10. Okay, so how does this work? Let's say that I have 100, let's say I want to express this guy in scientific notation. The way I would do this is I want to create C that is between 1 and 10. So I would go ahead and, what's that going to be? What number is going to have to be 1? It can't be 15, right? It has to be 1.5. Good. Because it has to be between 1 and 10. Right? Now it's going to be times 10 to the third. Okay, the way we find third is we're going to go from here, we're going to count 1, 2, 3. 3. So it's a number of places you had to go from the end to establish the 1.5. So if you look at this, this is 1.5 times 1. 10 to the third is 1,000, right? So it's 1.5 times 1,000, 1,500. Makes sense. Okay. So let's try this out. Let's do this. Okay. So the way we're going to do this is just like we did before. We're going to start from here. We're going to count 1, 2, 3, 4, 5, 6, 7. That will give us 2.7, right? So it's going to be 2.7 times 10 to the, I moved it 7 places. That make sense? That makes sense? Okay, so this is fairly easy to see when we're going from here in this direction. And there will be times when I go the other direction. So in other words, if I have a number that looks like 0.00124. Again, I'm going to have to try to establish a number that is 1 to 10, right? And what would that be?
Would that be like 1.24?
1.24, right? It'd be 1.24. In other words, you're going to have to move this guy, the decimal point, from here to here, right? So let's count how many times, how many ways I have to go. I have to go 1, 2, 3, right? That's 3. So it's going to be 1.24 times 10 to the negative 3 because I went this way. Okay? Which also, luckily for you guys, happens to be the number of zeros. 1, 2, 3. So you can kind of do that too. You can count the number of zeros and put it up here, which comes into play where like this, right? The proper way to do it would be from here, count 1, 2, 3, 4, 5, 6, 7, 8. Right? 9.8 times 10 to the negative 8. or I can count the number of zeros. 1, 2, 3, 4, 5, 6, 7, 8. And do that. Right? Works both ways. Now it kind of gives you also it gives you a feeling for why scientists use this, right? If you didn't have this, you would have to sit there here and write all these zeros, right? Which is okay until you come to a number like has anybody seen this number before? Nope. Nope. Okay. Bring your phones up. Go ahead and somebody Google what the name of Trader Joe's avocados guacamole is. Huh? What does it say? What is it called?
Avocado number guacamole.
Yeah, Avogadro's number, right? Not avocado. It says Avogadro's number guacamole, right?
Yes.
That's a play on words because Avogadro is close to avocado. This is what Avogadro's number is. This is a very famous number which you will use in chemistry. It is the number of molecules in a what we call a mole. Okay, just letting you don't have to know this. Okay, but what I'm saying though is that if you wanted to write this out, and you see how cumbersome this would be, you're gonna have to put 1, 2, 3, 4. How many times? 23, right? And this is exactly why we use the scientific notation. Because nobody wants to sit there and count zeros, right? Okay, so this is why we use scientific notation. Okay, so let's see if we can do some of the examples now. Example number 1. Example number 1. The retina has that many rods. Write this number in scientific notation. So I have number 1. I'm going to go from here. I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. 1.2 times 10 to the 8th, right? That's how many numbers I have to go over. Okay, so that's 1, and the other one is the thickness is in meters. Write this in a number of scientific notation. I have 1.12, which is going to be equal to 1.2, right? 1, 2, 3, 4. 10 to the 4, but I'm going in that direction, so it's -4, right? Okay. Let's go to example number 2. Write 3.2 times 10 to the 7th in standard form. So now we're going to go from scientific notation to standard form. So I have 3.2 times 10 to the 7th. So it's going to be 3.2. I'm going to move this how many times? 1. Well, let's go ahead and write the zeros out. I don't know how many we're going to have, but let's kind of write as few just in case. 1, 2, 3, 4, 5, 6, 7, right? Yeah.
Could I be excused really
No.
quick?
Why? I'm just kidding. Hey, what?
My dad's calling me for something.
All right. Come back as soon as you can.
Okay, thank you.
Okay. So everybody see how we went that way?
Yeah.
Right? Went that way? Okay. So that was A. The other one is 8.69 to the -5th. 8.69 times 10 to the -5th. So we're going to go the other direction because it's negative, right? We're gonna go from here, so let's go ahead and write some zeros here for us. We're gonna go from here, we're gonna go 1, 2, 3, 4, 5. Right? So it's gonna look like this, right? 1, 2, 3, 4, 5. Number of zeros, right? Remember we said that it will be the same number of zeros, the number of zeros right there. Okay. Example number 3. Order from the least to the greatest. So this is a kind of a two-step process here. Example number 3. Right, okay, okay. Right, 3.9 times 10 to the 6th. And then 3, 8, 1, 2, 1, 2. And 4.2. Okay, so we're going to write this from least to greatest. Okay, so what are the easier ones to compare here? Could be this one and this one, right? Because they're both 10 to the 6th, right? They both have the same exponents here. This is 3.9, this is 4.2, which means that obviously this one would be smaller, right? This will be smaller, right? This will be smaller, okay? So now I just have to find out where this guy's going to be at, right? So if I go from here, I go 1, 2, 3, 4, 5, 6. So it's going to be 3.8 times 10 to the 6th. Oh, now we go, right? Now they're all 10 to the 6th. Lucky us. Right? So I can go say this is the smallest. This is the next. This is the largest, right? Does it make sense? Okay. Okay. Sometimes you're not going to have where they're all the same. Let's say that I had one was like 1.2 times 10 to the 5th, and the other one was 9.9 times 10 to the 4th. Which one is larger between these two? This one's a larger?
Yeah.
Why is this one larger?
Because that one's, yeah, that's
Because the exponents is higher, right? This is 5, this is 4, right? So if you actually do the math, you're going to get 1.2, and I have to move this 5, right? 1, 2, 3, 4, 5. And this one is going to be 9.9, 1, 2, and I have to move this 4, so I'm going to go 1, 2, 3, 4. So I'm going to end up with this. Now you can see that this guy is smaller, right? Even though it has the larger 9.9, because this is only to the 4th and this one's to the 5th, right? This one's going to be larger. Okay. Example number 3, let's do example number 4. Example number 4, a Wolffia plant is the smallest flowering plant in the world. One Wolffia plant has a mass of that many grams. At least you could fit in a thimble. What is the mass of that many plants? So if I have this many Wolffia plants, and each one of them is going to weigh 1.5 times 10 to the negative 4, 1.5 times 10 to the negative 4th. And this is what I'm doing. I'm multiplying those two together, correct? That's what I'm doing, right? So the way you do this is you're going to multiply the numbers together, and then you're going to multiply these guys together. 5 times 1.5 is 7.5. Times, now I have 10 to the 3rd times that. They're the same base. And remember we talked about the exponents, right? The exponents, you can just combine them. So it's going to be 3 minus 4, right? Because I have minus 4 here. Okay, so if I do that, it's going to be 7.5 times 10 to the negative 1. In scientific notation, this is what it look like. In real life, this will be what? 7.5. So I'm going to move it this way, right? Because I'm going 0.1, 1. So I can move it 1 there, right? So this is the same as 0.75. Okay, any questions there? All right, let's go ahead and get working on the homework then.